So here actually we're doing question number 14. So that is actually the derivation of the derivation of the suvat equations, mainly these equations. So v equals to u plus at. This is actually quite obvious because it deals with you already know what that is. A is equal to v minus u by t. That is, if the acceleration is constant, that is the prerequisite for all the suvat equations. That is, a is equal to v minus u by t. So acceleration is constant. So it will be what? Change in velocity divided by time. Change in velocity is going to be final velocity minus initial velocity. Also, you could actually look at it in a very intuitive way. Let's say the acceleration is equal to 10 meters per second square. The value of A is 10 meters per second square. Let's say downwards. So this is actually what? 10 meters per second square is the value of g. Okay, the gravitational acceleration. So let's say you drop a ball. Okay, so the initial velocity is 0. So at time t, well, the initial velocity and if you take only the time is like 0, so v will be just equal to u. There is only one velocity, the initial velocity, and that is also if you take only that time, it's also the final velocity. So let's say 10 meters per second square, the acceleration, what it means actually, 10 meters per second. That is, if the 10 meters per second square is downwards, that is vertically downwards, then the speed is increasing 10 meters per second every second. So initially the velocity is 0 meters per second. So after 1 second, the final velocity, it will be what? What will be the velocity after 1 second? It's going to be 0 plus 10 downwards. After 2 seconds, it's going to be what? With this, again you add 10. So it becomes 20. So it is actually 10 into 2. After 3 seconds, you add 10 to this again. So it is 10 into 3. So this is sort of an intuitive way to understand. So since acceleration, let's say whatever the value, say a meters per second square. So what it means that the speed is changing by a every second. So meters per second square, you can actually view it as meters per second per second. So every second you are just adding a to the initial velocity. So now, and this formula actually more or less is derived graphically. So later I am going to discuss graphs. So this formula is easily derived graphically. Now the main task of this question, the question number 14 in the book, was that these two formulas are, these two formulas. So how you can derive the other formulas. So in this equation, so u plus v, you have u and you have v, and you know what? The value of v is u plus at. So instead of v, I can actually write u plus at. So this is, and there is a t outside. So 2u plus at t. If I simplify, this will be ut plus half at square. Okay. So this formula already it is derived. Now you can derive this formula on your own. How? Instead of u, you can actually write v minus at. In this formula, instead of u, you can write v minus at, and then if you simplify, you will get this formula. Now let's look at how we get to v square equals to u square plus twice a s. So let me square this. V equals to u plus at. So v square is equal to u square plus 2u at plus a square t square. So u square plus twice a ut plus half at square. So u square plus 2u at plus a square t square v square. Just I am squaring this. Now u square is there. So from this part I am taking 2a common. If I take 2a common, I just get ut plus half at square inside the bracket. So this is equal to s. We have already derived. So v square is equal to u square plus twice a s.